So here's some more solving compound inequalities. And on this one, we're solving and writing the solutions in interval notation. And so first we solve. So we subtract 9 on both sides. So x is less than -9. Or we're dividing by 4 to solve. X is greater than -3. Now we want to put this on the graph and interpret what it's saying, based on the fact that this is an OR inequality. It is still a compound inequality because there are two inequalities here. All right, so x is less than -9. So we're going this direction. Or x is greater than -3. And then we want to write that in interval notation. So this is another one of those that is going to be using the union, right? So -infinity to -9, union -3 to infinity. I don't want that to look like a V. I'm not very good with my union symbols. So that's basically saying all of this is in my solution set. Any number that's less than -9, any number that's greater than -3, all of those are in my solution set for this particular compound inequality. All right, here. So I was starting to say, here is our next inequality, and then I paused it, so you may hear me say that twice because my screen was blank and I had to do my work around when I have weird stuff happening. So anyway, this one is a compound inequality that has decimals also. This is an and. Okay, so now you could have and or showing up. And on this one, we're going to solve on 3 parts. So we're going to subtract 0.8. Right, so now we are going to have, and you could go through and multiply that. You know what? I'm going to do that. Let's clear the decimals. So if we clear the decimals, notice all of them have 0.1 place after the decimal to the tenths. So if we multiply everything times 10, then we can clear these decimals, and it's really just easier to do that. We'll go back to decimals at the end, basically, if that makes any sense. So this is going to be -7. You just move your decimal 1 place to the right. 4x plus 8 is less than 5. And then we solve, so subtract 8 on all 3 parts. -15 is less than or equal to 4x, and that's less than -3. Divide by 4. So -15 fourths is less than or equal to x, and that's less than -0. Oh, no, let's not write that. Let's leave it as the fraction, and then I'll switch it to the decimal, -3/4. When you have one like this on my lab, it will allow you to use decimals because it was a decimal inequality in the first place. In decimal form, it's going to be -3.75, and it's going to be -0.75. And so we can put this on the graph or not. Notice it just says write the solutions in interval notation. This one we know goes from -3.75 to -0.75, right? It's a compound inequality, and that's the interval notation for that. Okay, so this is the last example that I have for you. And let's solve this one. Okay, so this one is an OR. So now remember, you want to pay attention. Are we looking at an and or an or, so that you can use the appropriate thought process, right? That's really what happens here. You've got to think about this, right? So x is greater than, right? I have to switch the direction of my inequality because I'm dividing by a negative, is greater than 3. And on this one, I'm going to subtract 1 and then divide by negative 1. So x is less than 3. Now this one's probably going to seem kind of weird when we put this on the graph, but there are some like this. This came from the textbook. That's where I get my examples, is from the textbook. And then the problems on my lab are based on the textbook. So this should hopefully make sense to you when you look at it. All right, so greater than 3 is going to look like this. But we're also less than 3, or, right? So I don't know if this makes sense to you. I'm just going to write a 3 kind of here between these. Everything is in this solution set except 3, okay? Because it's greater than 3 and less than 3, but 3 is not included. So we have to write our interval based on that. Negative infinity to 3, not included. Union 3 to infinity. So here's how we say all real numbers except 3. Right? 3 is the only real number that is not in our solution set. All right, so that's it for this lesson.